So in our extended model with the two consumer groups, the total market share of product J is basically just the weighted sum of the market share of the two consumer groups. So if Wi measures the relative size or the share of consumer group I, the total market share is given by this sum. Or in our example, where both consumer groups have the same size, it's just 1/2 of the market share of product J within consumer group 1 and 1/2 of the market share of product J within consumer group 2. And if we look now at the price derivatives, we essentially find that it's the weighted sum of the price derivatives for each consumer group. So if we differentiate this sum with respect to some price pH, we get this formula. Or in our example, essentially because we assume that for each consumer group, or within each consumer group, demand is described by a conditional logic model, it would mean that the price derivative is 1/2, that's the size of consumer group 1, times here the simple formula, alpha times S1J times S1H, and the same for consumer group 2. So this looks still very simple, this formula. But if we compute now these cross price derivatives, so assume that the price of the sports car A changes, and we want to look by how much percentage points does this change the market share of product B, then we find basically the following formula. Here I simplify it a little bit. I multiply out the 1/2 alpha. And here we have the product of the market shares of car B and A within consumer group 1. That was the consumer group who liked sport cars. So both have a market share of 1/2 there. So 1/2 times 1/2 is 1/4, multiplied by another 1/2, which we have factored out, is 1/8 multiplied by alpha. So we have a positive cross price effect of alpha divided by 8. Now let's compute how much a price increase by 1 unit of the sports car changes the market share in percentage points of the family car C. So we also have the simple formula, but here basically we have the product of the market share of product C in group 1 with the market share of product A in consumer group 1, and the same for consumer group 2. Now the thing is that in consumer group 1, the ones who like sports car, the sports car A has a market share of 1/2, but the family car has a market share of 0, and 0 times 1/2 is 0. And in the other group of the family cars, we have a market share of 1/2 for the family car C, but a market share of 0 for the sports car A. So we again have 1/2 times 0, and the sum is 0. So the total effect of the price increase of the sports car A on the family car SC would be 0. And that's what we want. And not what we want, but here we have different substitution patterns. So we see that the price increase of the sports car A has a bigger impact on the market share on the other sports car B than on the family car C. And here we have a very extreme example where one product has a 0 market share within one consumer group, but think of that maybe family car C has a very small market share in consumer group 1, and the sports car A has a very small market share in consumer group 2, then we also would find that here we have a smaller total effect. So this means even though for each consumer type we have this very simplistic formula for the cross price derivatives, by assuming that we have different consumer types, so one consumer type who really likes sports cars, the other who really likes family cars, we can get nice, complex, flexible substitution patterns with respect to the total market shares. In particular, we can here now model the effect that a price increase in the sports car has a bigger impact on the other sports car than on a family car. And maybe let me add that for the exam, you should know this simple formula of the cross price derivatives of the conditional logic model without consumer characteristics. And you should also be able to perform computations like we have done in this example. So you should be able, if we have two consumer groups, maybe with some different market shares within each consumer group to compute the cross price derivatives. And you should be able to understand intuitively this example.